fix it.
Okay, yeah. Are we ready?
Yeah, I'm always ready.
Okay,
So
can I
the
start?
stage is yours. Yes.
Perfect. Hello, everybody. Hi. I'm so excited to be at OS Days this year. Yesterday was a great day, and I met lots of cool people and had great conversations. And hopefully this is going to spark more interesting conversations at lunch. What I'm going to talk about today is LavinMQ. It's an open source message broker that we developed in-house at 84Codes, which is the company that I work for. The cool thing with LavinMQ is that it produces really awesome throughput performance while writing all of their messages persistently to disk. So first, I'll go through some background and message queuing theory, just so that we have a baseline established for everybody. And then I'll go through LavinMQ, and I'll tell you about how we achieve these results and what's special with the architecture. And after that, I'll show you some benchmarks, and I'll round up with some takeaways. But first, I just want to take a minute to introduce myself. My name is Christina. I'm based in Stockholm, Sweden, which is currently very rainy and cold. So flying over to Italy and seeing Florence is really, really nice. I'm a software engineer at the company 84Codes, where I also work as a project lead for the LavinMQ project. And I've been at 84Codes for about 3 years now, and before that, I studied a master's degree in computer science at a university in Linköping in Sweden. And in my free time, I like to travel, and I like to ski, as you can see by the pictures. And that was a quick introduction of me, but I also want to say a few words about 84Codes. So 84Codes is the group of people behind the more well-known platform, LavinMQ. And that platform hosts configured message queuing services. And LavinMQ, it provides RabbitMQ as a service, which is an open source message broker. How many of you have worked with message queuing or have heard about RabbitMQ before? Okay, that's a fairly good turnout. That's nice. Thank you, guys. So RabbitMQ is one of the more popular message broker alternatives out there. And we've been in the business of hosting for about 10 years now. And recently, 84Codes, we launched our own message broker called LavinMQ. And that's what I'm here to talk about today. So first, I want to touch on what message queuing is for those of you who didn't raise your hand. And I'll go through some basics just to have everybody on the same page from the start. OK, so what is message queuing? And message queuing, it's a solution used in distributed systems. An example could be a microservice architecture to enable asynchronous communication between components or services in your architecture. And here you see the most simple example of a message broker with one single queue. Here, a publishing service and a consuming service are able to send and consume messages to or from this queue. So the picture here shows the difference between synchronous and asynchronous communication. In the left picture, we see synchronous communication where messages are sent directly from one service to another. Here, service A will send a message, and then it will have to wait for service B to finish handling the request before it continues on with whatever activity that it was doing. On the other side, we have asynchronous communication. Here, service A can send messages to a queue, which will facilitate that message and take responsibility for delivering it safely. This means that instead of waiting for process B, it will receive a super quick acknowledgement back from the queue, and then it can carry on doing whatever it was doing while service B fetches that message from the queue and handles it in its own time and at the capacity that it's capable of. And this will save your service from potentially overloading if there's a sudden increase in workload. Instead, the messages are buffered in the queue, and your services can handle them whenever they're capable. And just to illustrate this for you, I have the example of building a web shop. So let's say that you launch a web shop built on a microservice architecture, but you do it without having heard about any asynchronous communication methods or message queuing. So you build a couple of different services. For example, you have one for handling your inventory, one for registering orders, and one for making payments. And when a customer goes to buy an item on your web shop, at checkout, they'll fill in all of their information, and then they'll just click Pay. And your system will send that request to your payment service. And the payment service will start to handle this request. However, it will need to connect to whatever bank that you have, and that can give an unpredictable response time. So this means that the checkout service and ultimately the user is left waiting for a little while until the payment is finished processing. But sooner or later, it will finish, and it will send back confirmation on the payment, which can then be communicated to the customer. But like I said, during that payment process, the payment process, the customer will be waiting in a synchronous way for the screen to show some sort of indication that something is happening. And this is a pretty bad user experience. When you click and nothing really happens, it's kind of scary, especially with all the sensitive information that you put in when you pay for something. And especially if you have a request that takes a long time to process, and maybe you have a lot of those requests as well. Say that you're having a sale on your website, and a lot of new customers are coming in, and you're not prepared to handle that load. Then you can easily overwhelm your web server and give an even worse user experience. And with message queues between your services, you can eliminate the waiting. And I say eliminate in air quotations because, of course, your payment service still has to process the payment, but with asynchronous communication in the picture, you're able to return instantly to your customer with a promise that your order has been placed and that the receipt will be sent to them later. Or you can at least update them that something is happening, because the worst experience, like I said, is really when a user puts in all of their sensitive information and then they click and nothing really happens. So this is an example of where message queuing can fit into your architecture. Okay, so now that you're warmed up on the concept of message queuing, I can explain to you how we came to build LavinMQ in the first place. Okay, so 84Codes has been running Cloud AMQP for a while now, and we're providing hosted and configured RabbitMQ services in different sizes and capacities. And by then, or back in the day, we had a couple of users running RabbitMQ together with their PHP clients. And these PHP clients would open connections to the RabbitMQ server for every single message that they were sending. And these connections were pretty short-lived connections. And the consequence was that a lot of these connections were opening and closing towards the RabbitMQ server. And a high connection churn like this can be pretty heavy for the RabbitMQ server's CPU. So it wasn't uncommon that the resource would become overloaded and we would have troubles with these clusters. And to deal with this problem, we had the option of upgrading the users to a larger underlying instance type for the server, but that would be both expensive for the user and for us, and it doesn't solve the underlying issue. And that's not great in the long run, because someday you might want to send even more messages, and you might have to scale up again. And the other option that we have was to build some sort of solution that could help us handle the connection churn. So we built a solution for these use cases where they could use a proxy layer that would be able to keep the connections alive. And the proxy stores connection credentials, and it maintains a connection towards RabbitMQ, while the PHP client opens a connection to the proxy. Using those credentials, the proxy reuses that connection to RabbitMQ. And like this, we were able to keep the connection churn pretty reasonably low, and the underlying CPU issue was solved. So we called this the AMQP proxy, and AMQP stands for the Advanced Message Queuing Protocol, and it's the protocol that's used in RabbitMQ. We use it in LavinMQ, and a lot of other message brokers use it as well. And the AMQP proxy, it needed to support a large number of functionalities of the AMQP protocol, of course, for us in order to be able to use it against RabbitMQ. And after a while, the project became so extensive that we started talking about how hard would it actually be to just build the whole message broker? Now that we've already worked so extensively with AMQP proxy, how hard would it be to just run the whole thing? So now it proved to be a lot of more hard work, and it's not just an extension of the proxy, but it wasn't out of reach, and that was the important thing. in 2018, 84Codes decided that we would launch a project to build our own message broker that would focus on resource-efficient edge cases and high-throughput performance in order to help us with use cases like these PHP clients. And back in 2018, this project was called LavinMQ, but that was trademarked by a gaming company, I think. So we changed the name to LavinMQ. And Lavin, or Lavin in Swedish, is the word for avalanche. So we put a little bit of a personal twist to it. It's a fun fact that I like to mention because I think it's funny. So now I want to move on to talking about what makes LavinMQ special. And I'm going to start with addressing the clickbait of writing to disk being faster. And practically, this is not true. It's well known that the in-memory access is much faster than the disk access. And I'm sorry to disappoint, but I have not invented a new super fast method to interact with the kernel. I wish I had. But what is true is that LavinMQ actually does write every single message persistently to disk, and it's still faster than other AMQP alternatives. And I guess the interesting question is, how does that even work? Well, there are many things that go into making LavinMQ what it is, but three big topics are writing code that executes really fast, avoiding system calls, and a subcategory to that is using mmap to manipulate files on disk. And beginning with writing efficient code, it's important to choose a language that suits your application's purpose, right? And at 84Codes, we mostly write code in Ruby, which is a great language for many reasons. It's productive and it's expressive, and it works great in a lot of areas that we work with. But it's not ideal for performance-sensitive applications. So when launching projects like LavinMQ, there has to be a different approach, and instead we chose to build LavinMQ on a language called Crystal. And Crystal is a compiled language, and it uses the LLVM compiler to compile down to bytecode, which is much faster and more efficient to run. And along with this, the syntax of Crystal is very, very similar to Ruby, so it's very efficient for us as a Ruby shop to be working with Crystal. And it shares the qualities of being so expressive and nice to read and write, so shout out to Crystal. It's a great language. You should check it out. Other than that, choosing an appropriate language, it's important to be mindful of how you implement your code. And for LavinMQ, we identify what we like to call hot code paths, which I've tried to illustrate here. I don't know if it's super clear, but that's a hot code path. Those are paths that we know are performance critical, where we have to be extra mindful of performance impact. And this can be in the form of being careful with, for example, heap allocations, and knowing what type of memory we're allocating when we're using a data type or a method. And sometimes in these hot code paths, we have to find workarounds in order to avoid allocating stuff, for example, on the heap memory, because it's a bit slower than using the stack memory and stuff like that. And a good way to ensure your changes aren't impacting the performance is to use benchmarking tools and other performance measurements when you're making changes in these hot code paths. Okay, so another performance measure is that we try to avoid syscalls like the plague, as much as we can, because they are pretty expensive to do. And syscalls are made when a user-level program needs to perform operations that can only be done on a kernel level. So for instance, that could be opening a file or reading and writing to a socket. And what makes this expensive is the context switching between user and kernel mode. And making a lot of repeated syscalls can add a significant overhead to your system. So on a day-to-day coding level, we try to just avoid making syscalls in the hot path of the code. But on an architectural level, we have also had to try to minimize the amounts of syscalls wherever we can. And you can imagine that our application has the potential to make a lot of syscalls when we're reading and writing messages down to disk at like a speed of thousands, hundreds of thousands of messages each second. So normally, the way to access a file on disk is to just open a file descriptor and issue read and writes to that and with syscalls and manipulate your file how you need to, and then you close it again. But in LavinMQ, we use another method called mmapping files. And this means that we allow the operating system to create a link and map a file directly from the process's address space. So now instead of using traditional read and write syscalls to page data up and down to disk, the application can directly access the file content as if it were in memory. But we're not done there, and to optimize this even further, we do what we call M-mapping on demand. And this means that we unmap the files that are not currently in use by the message broker. So if you're not reading or writing a message, we will unmap that message segment in order to free up allocated memory that's not in use. And when the message segment then later needs to be accessed again, we will map it again with the mmap syscall. And that way, we can prevent unnecessary memory space being allocated and use the process memory as efficiently as we can. OK, so that was a bit of background on why LavinMQ is fast. But now I'm going to show you that it actually is fast. And I've done some benchmarks on 2 more or less identical servers. The only difference is that one is running LavinMQ and one is running RabbitMQ. And they have the same underlying instance type, which is an AWS instance called T4G small, maybe, yeah. It has 2 CPUs, 2 gigabytes of memory, and 10 gigabytes of disk space. So the only actual difference is the software that's installed on the server. And the test that I have run on these servers is a throughput test. And we're counting the numbers of messages the broker can handle going through the queue every second. I have used our own performance testing tool. It's called LavinMQ Perf, which is compatible with the AMQP protocol. So it's what I call message broker agnostic. And you can work towards both LavinMQ and RabbitMQ and any other message broker that behaves in the same way. And it's also open source, so you can go and read how it works if you want to, and if you're curious, you can try it out for yourself. I have run these throughput tests on each server with default settings. That means that we have pretty small message sizes. It's 16 bytes per message, and I have 1 consumer and 1 publisher. And this test will let one publisher publish as many messages as it can. It will let the message broker account for that message and handle it, and then it will let a consumer consume those messages as fast as they can. And to really push both brokers, I have put no publish confirm requirements, so it should be a really just clean flow, like I've tried to illustrate here. And without further ado, the results show that LavinMQ has about 3 to 4 times higher throughput, pushing around 150,000 messages per second, while RabbitMQ is able to push around 45,000 messages per second. So now we can keep in mind that this is a pretty small machine, and with larger resources, we can push up to over 1 million messages per second with this test case on LavinMQ. So yeah, now I just want to round up what I've been talking about, beginning with a little bit of message queuing theory and inspiring you guys to go build your own web shop. But remember to do it with a message broker. And then I want to talk about LavinMQ's origin story. And I told you about how we fixed our PHP client problem with the AMQP proxy. And then we went through what makes LavinMQ special, talking about how we use Crystal and writing efficient code. And after that, we touched on why syscalls are so expensive. And in a read and write heavy use case like ours, you can win a lot by trying to just avoid them. And then we touched on M-mapping and how that helps us avoid making a lot of those syscalls that otherwise would be necessary. Yeah, and with that, I want to say thank you so much for listening. I hope you got interested in LavinMQ and checking it out. So I put up some QR codes to link to our GitHub and to our Slack. I'd love to chat about your use cases, so please feel free to join the Slack channel. And if you have any questions, I'm here to answer them. Thank you. Woo.
Well, Christina, amazing talk. And right on time. So, super.
Awesome.
So, I will just give you a trophy.
Thank you. This is so cool.
This is more than an Oscar.
Of course.
It's true. It's true. Johnny Depp, Leonardo DiCaprio, I mean, poor guy. So, Q&A. Of course, there is always this guy.
Okay, you didn't tell us what kind of disk were you using for the benchmark? Was like SSD?
Yeah,
NVMe?
SSD.
Okay.
Yes.
So what kind of disk is it optimized for? Like.
That's a tough question. I don't really know. I'd have to go into our servers and check out exactly what disk. But I can come back to you on that, and I'll just check it on some test instance that I have, and then I'll tell you.
Hi.
Hi.
Can I ask what kind of the queue did you use for the test? Quorum, Classic, and if you use it Classic, what kind of the index, the new one or the old one?
The Classic queues, and I think it's new Classic queues.
The version 2?
Yeah?
All right, thank you.
Thank you.
And guess who?
Hello, and thanks for the talk. I noticed that you mentioned you're using a map, and like a year ago or something like that, there was a series of articles saying that a map is considered as harmful in using in read and write intensive applications. So for example, when you write something to a map, there is no guarantee that it will be flashed on the disk, so you can't respond to the client with guarantees that this message will remain there. And also there are problems with concurrency access, when many concurrent threads write into the mapped file. Have you seen these implications in your application?
It's a good question. I think it's very rare for us to run into an issue like that. I have never seen it, but I have also read articles about it being dangerous or what you can say, but I personally have never seen it, and I think it's very rare for it to happen, especially when you have like a good implementation of it.
Okay, and in this benchmark that you showed, was there a requirement for memory on the machine when your message came?
No, this is just like the throughput test is for us to kind of push the message broker as fast as we can. So we've kind of have no checks or like safety measurements there. But yeah, it's just to get the fastest numbers. You can put in all of those things in the LavinMQ perf tool also if you want to check those. But I think it's funnier to see numbers that are like at the optimal speed.
Okay, so you would expect the same stats of this benchmark if we set, for example, 1 gig of memory available for your LavinMQ application here?
Sorry?
Like if we reduce memory, allowed memory for LavinMQ in this benchmark, will you expect the same numbers after this?
No, I think numbers can vary a little bit, but I think they're still impressive compared to what is available. Yeah.
Okay, thanks.
Thank you.
Because he's such a good guy with good questions, right ones, and I'm just enjoying. It's super to have speaker and attendees like him in this room. So, any other questions? Because the level is right here now. No one? Here, the challenger.
Quick one. Do the performance remain stable as you increase the number of producers and consumers?
Yeah, I would say so.
So no degradation at all? If you just,
Sorry, no.
Degradation of performance?
Not what I have seen when I've run my own tests, but maybe like if you have some special use case. Of course, this software is like use case, kind of, it caters to edge cases. So if you have something that is super cumbersome for the message broker, then of course the performance will be affected. But I would still say that for that the performance is impressive, even if you tamper with different checks and safety measurements and more producers or less producers. I mean, of course, the performance will vary how you when you put in different variables, but I would still say that it is impressive.
Okay, thank you.
Thank you.
Hi. I just wanted to ask if LavinMQ is made with high availability in mind. You know,
So,
if it's
high
availability. If it's
High-
fault
no, okay,
tolerant,
yeah,
if
right.
it can be used.
That's also a very good question. Currently, we offer LavinMQ as a single node broker. So RabbitMQ is, of course, like the big beast, which is a big toolbox that can be used for many very good use cases. And LavinMQ is more of like it goes in and pinpoints those use cases that are kind of difficult to cater to with a bigger and more powerful tool like RabbitMQ. No, we don't have clustering, but we have started implementing replication so that we have data safety at least. But yeah, maybe it'll come in the future. You'll have to stay tuned on our GitHub page for that.
Can you hear me? I'm here.
Hi.
Hi. First of all, I would like to apologize because I didn't follow your speech from the beginning.
Okay.
So I don't know if you maybe mentioned this or not, but I use Kafka.
Cool.
Yeah, not cool, right? Debugging.
You use Kafka.
Yeah. So what I would like, I was talking to my CTO and we wanted to go to RabbitMQ and we didn't.
Okay.
So what I would like to ask you, if you could tell me, you probably did all your research regarding Kafka versus LavinMQ. No, not really. But I want to go back to him and I want to suggest him to use what you guys just presented
Yeah,
here.
you should.
So if you could just tell me what would be the major points that will make our life easier, especially when it comes to debugging, because we know that Kafka to debug is like, right?
Right.
Like maybe some of them
Yeah.
now, and then I maybe catch up with you later. and
I
you
would
can
love
give-
to talk to you after
Yeah.
as well, but what I can say is that LavinMQ is a pretty lightweight alternative to use. It has stream queues, so just like RabbitMQ. So the line between Kafka and LavinMQ is kind of blurry, but yeah, it's a simpler tool. It doesn't need as much configuration, I guess, and debugging. And at CloudMQP, we have stellar support system. So if you would use CloudMQP, you would get like a really good help with debugging any use case problems that you have. And yeah, we also have a really good chance of actually making improvements to the software depending on what our customers want. So if you have any issues, we could probably just work something out between you guys and us.
Right. Thank you. And one question, so what would be your main, like what is it that makes you different from all these other tools? Just one thing, because I'm going to go now in a meeting with my CTO and I'm going to smash him with whatever you guys have, because it seems way simpler, right?
Right. Yeah, speed and simplicity. I would say it's a very easy tool to get up and running and start working with. And as I showed you, it's pretty fast. So, yeah.
Thank you.
I can add a friendship with Christina, so maybe a consultancy or
Yeah.
whatever. Because Christina needs money to ski, and for I ski.
Yes.
By the way, I was in Stockholm recently.
Yeah, I just want to add, if she's interested on RabbitMQ streams, I work for the RabbitMQ core team. And
I see you, yeah.
No, it's not a war. It's not a war. So we work together. I mean, they
Exactly.
contribute also in RabbitMQ.
Yeah.
Now, if she wants to know more about streams, I work on that part. So.
Yeah, awesome. Yeah, you can talk to him as well.
Can we create a council here for RabbitMQ and this improve performance and whatever?
But what is better?
There is a conference
RabbitMQ better
for RabbitMQ.
or LavinMQ? I don't know.
We need to
I don't
create
know.
another open debate for that.
Yeah.
We should.
I mean,
But is it going to be a violent debate? Now that's the
no,
question.
that's bad,
Yeah,
that's bad.
yeah. You never know. Violence is not the answer.
No.
Unless it is. Who knows? Who knows?
We're all working together. This is open source, so.
By the way, if there will be a war, I choose Roman as a champion.
Perfect. Yeah. Okay.
So, any other questions? No more.
We're good.
Very good. So, thanks again to Christina for this amazing talk.